Welcome to Sir J Maths. This is our second episode, second video on hints and shortcuts in computation of maths. Now, our objective is to show that maths can be made simple. And CXC is approaching, multiple choice, and I am here to help guide you into acing that exam. You really want to know certain tips in order to do very well. Now, let us say we have 0.625 to be multiplied to 32. Now, you want a shortcut way of working out this. If you know that 0.625 is 5 over 8, have that in your mind. So 5 over 8 times 32, by knowing your timetable, 8 into 8 is 1, 8 into 32 is 4 times, and 4 5s give us 20. See how quickly we arrive at our answer. Also, if you get 0.125 to be multiplied to say 44, if we know that 0.125 is 1 over 8 times 44, and we can use, say, 2 into 8 is 4, 2 into 44 is 22, 2 into 4 is 2, 2 into 22 is 11. So what we have here is 11 over 2, which is the same thing as 5.5, which is the same thing as 5.5, since 0.5 is the same thing as a half. Now what if you get 0.5 to be multiplied to, say, 22? Now 0.5 is the same thing as a half, so it's half times 22, 22 1, 2 into 22 goes 11, so 11 ones actually give us 11. So these are certain things that you need to know for the exam. 0.5, we also have 0.75, which is the same thing as 3/4, and 0.75, which is 3/4. So if you get 0.75 to be multiplied, say, by 56, then you can have 3 over 4 times 56. And you can say 4 into 4, 1, 4 into 5 is 1 times remainder 1, 4 into 16 is 4. Now you have 3 to multiply to 14, so it's 3 4 is 12, 2 carry 1, 3 1 is 3, and 1 is 4. So these are the shortcut ways of basically multiplying. Now, what if you get a problem, say 299 to be added to 876 to be added to 1? And what we can do is to utilize the commutative law for addition, in which the order in which we add numbers together do not affect the sum. So we could add 299 and 1, we get 300, so it's 300 in our head, plus 876, that's 876. We add our digits here, 6 plus 7 plus that is 7, 8 and 3 is 11, so we get 1176 easily. Now let us say we have 25 to be multiplied to, say, 736 times 4. Again, we could utilize a commutative law for multiplication now, where the order in which we multiply numbers do not affect the product. So we don't have to multiply 25 to 736 first. We could multiply 25 to 4. And we know that 4 sets of 25 give us 100, so it's 100 times 736. And then what we can do is to utilize the zero trick, where we simply multiply this numeral here to the 1. 736 is times 1 is 736, and there are 2 zeros. We simply join that, and that will give us our answer. Now let us say you get something like this: 201 squared minus 199 squared. And you might be looking at this and say, whoa, how can they give us this to do in a multiple choice exam? But what you need to be cognizant of is that there's a short way of doing this. Now here is the operation subtraction. This is a square. This is a square. So then this actually represents the difference of two perfect squares. And so if we refer to a minus b all squared, which is a difference, if we refer to a squared minus b squared, which is a difference of two perfect squares, then this 201 squared minus 199 squared is in the form a squared minus b squared. But a squared minus b squared can be written as a minus b times a plus b. So the same terms are actually in the bracket, except for the change or the difference in operation right here. So what we can do is to use the same, apply the same principle here for 201 squared minus 199 squared. So this will give us 201 minus 199 times 201 plus 199. So when we take 199 from 201, we simply have 2. And when we add 201 plus 199, in your head you can say, okay, if I had 200 to 199, I really get 399. And there's a 1 to be added, so then that will give us 400. So 2 times 400, 2 fours is really 8, and 2 times the zeros will give us zeros, or we simply do the zero trick by saying 2 fours is 8, and we just simply join the two zeros. So anytime you get something like this, just remember that it can be written as a difference of two perfect squares. So you don't have to write out 201 times 201 in order to get the answer, and 199 times 199 to basically get the answer. Now let us say you are multiplying, say 11, I don't even use 11, 12 times 13. Now there are different ways of doing this. Normally you would use 12 times 13, and you say 3 2s is 6, 3 1s is 3, 1 2 is 2, 1 1s is 1. So okay, then you have 6, then you have 3 plus 2 is 5. So we get 156 here. But you could also, here you are multiplying using one digit each time. But then you could also multiply using two digits. So we could say 12 threes or 3 12s is 36. We put on the 6 and carry 3. 12 ones is 12. 12 plus 3 is 15. So we still arrive at the same answer right here. Now also, if you know that 12 times 13 is the same thing as 12 times 12, because this is 13 sets of 12, so we can take out 12 sets of 12, which we already know as 144. Then basically you would add it. So this is 12 times 13 is really 12 sets of 12 added to another 12. So we could add 12 right here. And then 4 and 2 is 6, 4 and 1 is 5, and then 156, which is the same thing there. So there are different ways of basically multiplying that. Now also, if you have something like 11 times, say 42, again, we could say 42 times 11, 11 2 is 22, 2 carry 2, 11 4 is 44, and 2 is 46. And we basically end it right there. Now, timetable is an issue. A number of students, quite a number of you, actually are intimidated in studying the timetable. And you just cannot find that inspiration to study your timetable. But you need to know your timetable. Now there's a way that you can actually know it in the exam, in the event that you forget certain stuffs. Now your 2 times basically sums up the multiples of 2. And multiplication is what you call repeated addition. So if we add 2 plus 2 plus 2 plus 2, we get 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So when you have 2 1s, is really one set of 2. When you have 2 2s, is really 2 sets of 2, which actually give us 4. So if we add in 2, in a sequence we'll have 4, then we'll have 6, then we'll have 8. So 2 1s is 2, 2 2s is 4, 2 3s is 6, which is 3 sets of 2. 2 fours is 8, which is 4 sets of 2. So each time we are adding 2. So what you can see here is that multiplication is actually repeated addition. Now there's a pattern in your timetable, and let us examine this pattern. Now anytime you reach a multiple of 10, the first multiple of 10 in your timetable, or a digit that ends with 0, then everything begins to repeat. So if we go 2 ones is 2, 2 twos is 4, 2 threes is 6, 2 fours is 8, 2 fives is 10. So good, we have reached our magic number. So everything now begins to repeat in this particular pattern. So 2 fives 10, 2 sixes is 12. Now every numeral under these columns must end with the digit in the first column. So therefore 2 6 is 12, 2 7 is 14, 2 8 is 16, 2 9 is 18, 2 10 is 20, 2 11 is 22, 2 12 is 24. And you can do that for yourself. So the only thing you would need to know here is from your 2 ones, 2 2 twos 4 to the 5th multiple of 2 here, and everything begins to repeat itself. For 3 times, 3 ones 3, 3 2 6, 3 3 9, 3 4 is 12, 3 5 is 15, 3 6 is 18, 3 7 is 21, 3 8 is 24, 3 9 is 27, 3 10 is 30. And again, what you realize here, we have reached our first multiple of 10, which here is 30. Now everything begins to repeat itself, in the sense that the last digit of the numeral that you are going to write must end with the digit that is in our first row right here. So this is 3 11s is 33, 3 12s is 36, and we could go on. That's 39, and we're going up 42, 45, 48. So you don't even have to have a calculator to do that. For our 4 times, 4 ones is 4, 4 twos is 8, 4 threes is 12. Each time what are we doing? We are adding 4. So 4 fours is 16, 4 fives is 20. You don't need to know anything more, essentially. So what happened here is everything now will repeat in the sense of the last digit. So 4 fives is 20. Our 6th multiple of 4 then must be 24, because we add 4 to the 20, 24. So under this column we must have 28, then 32, then 36, then 40. So in other words, 4 6 is 24, 4 7 is 28, 4 8 is 32, 4 9 is 36, 4 10 is 40, then 4 11s must be 44, and 4 12s is 48. For our 5 times, just remember that every multiple of 5 must end with either 0 or 5. So 5 ones is 5, 5 2 is 10, 5 3 is 15, 5 4 is 20, 5 5 is 25, etc. So that is basically easy. For our 6 times, we know that 6 ones is 6, 6 2 is 12. So we add in 6 each time. Now 6 twos is 12, but 2 6s is the same 12, because of the multiplication or of the commutative law for multiplication. So 6 threes is 18, 6 4 is 24, 6 5 is 30. So we have reached our magic number here, and again our pattern begins to repeat. So 6 6s is 36, 6 7s is 42, 6 8 is 48, 6 9s 54, because it must end with a 4 here, and 6 10s is 60, 6 11 66, 6 12 72. So that basically is true right there. For our 7 times, you definitely need to know your 7 times. So let us look at our 8 times. 8 ones is 8, 8 twos is 16, 8 threes is 24. Now remember, 8 threes is 24. It's the same 3 times 8, which gives us 24. So each time we are adding 8. 8 fours is 32, which is the same thing as 4 8s. Now what we want to try and reach is our magic number, which is our first multiple of 10. So 8 fives is 40. Have we reached our magic number? Yes. So right here, everything begins to repeat. So 8 sixes is 48. So under this column, every numeral must end with 8. Every numeral here must end with 6. So 6 8 is 48, or 8 6 is 48. So 8 sevens now is 56. This one must end with 4, so it's 4 5 and 6, 64. Then we have 8 nines is 72, and then 8 tens is 80, and we can note we have 4 5 6 7 8. Now 8 11s is 88. That means we're adding another 8 to 10 sets of 8. And then 8 12s, we know that this must end with 6. So we have 96 right there. For our 9 times, please look at this carefully. Now 9 ones is 9. I can write it like this. 9 twos is 18. Each time we're adding 9. Now 9 threes is 27. 9 fours is 36. 9 fives is 45. 9 sixes is 54. 9 sevens is 63. 9 eights is 72. 9 nines is 81. And 9 tens is 90. Now before I even go further, let us look at something. Now here we have 0 as our first digit because 9 can be represented as 0 9. So let us check from down here. We have 0 1 2 3 4 5 6 7 8 9. Coming from up the top here, we have 0 1 2 3 4 5 6 7 8 9. Now it is of note that when we add the digits, we get 0 plus 9 is 9, 8 plus 1 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, 5 and 4 is 9, 6 and 3 is 9, 7 and 2 is 9, 8 and 1 is 9, 9 plus 0 is actually 9. So all of these digits actually add to give us 9. And therefore, one of the divisibility rule for 9 is that the sum of the digits, when you find the sum of the digits, for 9 to go into any numeral or any number, then the sum of the digits must be divisible by 9. So let us see something here. We have 9, we have 18, we have 27, we have 36, we have 45, we have 54, we have 63, we have 72, we have 81, and we have 90. So we will have reached our magic number there. So what happened here is that everything basically repeats in terms of the pattern. So 9 10s 90, 9 11s is 99, 9 12s is 108 because we are continuing. So in this row you will see something that we have 9, then 10, so we must have 11, and then remember our column must end with the last digit here, so that's 7, 11, then 12 must end with 6, then 13 must end with 5, then 14 must end with 4, then 15 must end with 3, then 16 must end with 2, then 17 must end with 1, and then 18 must end with 0. We have the simple interest on $400 for 3 years is $84. The rate percent per annum is. Now quickly you need to remember the simple interest formula as I equals to PRT over 100, where I is our simple interest, P is the principal, which is the money invested, the money lent or borrowed, R is the rate percent, T is the time in years. So when you look at this, what they're asking you for is a rate, which is R. Now you could do transposition of formulae to get R, or you simply have it in your head that R must be 100I over PT. So right up here, you quickly, while reading the simple interest on $400, you quickly write down I equals on $400. So P equal to $400. For 3 years, that's time equal to 3, is $84. So the simple interest is $84. So right here, I equals to $84. So we want R. So R equal 100 times I. That's 100 times $84 divided by P, which is 400, times T, which is 3. Again, you don't have a calculator. So what you can say is these two zeros cancel these two zeros. We can use, say, 4 into 4 is 1, 4 into 8 is 2, 4 into 4 is 1. Then we have 21 over 3. By knowing your timetable, 3 into 3, 1, 3 into 21 is 7. So everything is cancelled, leaving us with 7. So we look at our choices here, and we say that C is 7, and you circle C. 12, the most frequently occurring item in a distribution is called the, and once you hear about most frequently occurring item, that clearly is the mode. Now, as you know, the median is that value which lies exactly halfway of the distribution. The mean is the average when you add up all the numbers and divide by the sum of by the number of values. So while the standard deviation basically tells us by how much the values in the distribution differ from the mean that you'd have calculated. So if P operation Q means the square root of P squared minus Q squared, and we have seen where P squared minus Q squared is representative of the difference of two squares, which is underneath the square root sign here. What is the value of 5 operation 3? Now this topic, or this question, comes under the topic binary operations, in which you use two numbers to produce a third number by simply substituting the values for those two numbers, or given for those two numbers, into a given expression. So this is a given expression that you are actually get. So when I have P operation Q, because what happened, there are 4 basic operations in math: addition, subtraction, multiplication, and division. But you can come up with your own operations in order to work out some problems. So I have P operation Q, then I have 5 operation 3 here. This suggests that P is 5 and Q is 3. So what are we going to do with these two numbers now? As I said, it's a binary operation. So we are going to use these two numbers to produce a third number. So we simply substitute P, or 5 for P and 3 for Q, into the given expression. So it is P is 5, wherever I say P I put 5, so that's 5 squared, minus Q, which is 3, I put 3 squared. Again, you could say 5 squared, you know, is 25, 3 squared is 9. When I take 9 from 25, I get 16, and the square root of 16 is 4, in the sense of taking the principal square root, which is a positive square root. So we get 4. You know that this 5 squared minus 3 squared is the difference of two squares that can be written as 5 minus 3 times 5 plus 3. And we know that 5 minus 3, 3 from 5 is 2, 5 plus 3 is 8, so that's really 2 times 8, which is 2 8 is 16. And now the square root of 16, what number when multiplied by itself gives us 16? And clearly that number is 4. The area of the circle is 90 square centimeters. So this is representative of the circle with the center right here. And so the area, which is a surface that is covered, is actually 90 square centimeters. What is the area of the shaded sector? No. So it follows that the entire thing is really 90 square centimeters. And so here you have 120 as your answer. Now if the full area is 90, then it simply means that our answer must be less than 90. So when we look at these answers down here, you would realize that 120 is more than the 90, 240 is more than the 90, and 150 is also more than the 90. So clearly our answer has to be 60 square centimeters, which is C. So in other words, there are certain things that you didn't have to work out this. But what if you have to work it out? Let us prove. No, let us prove that our answer is 60 square centimeters. Now the full area is 90 square centimeters, and we know that the area of a circle is really pi r squared, and pi can be written as 22 over 7, or sometimes 3.14 correct to 2 dp, or 3.142 correct to 3 decimal places. And r actually represents the radius. Now what we do know here is that the angle at the center here for this, what you call minor sector, here is our minor sector, and over here is our major sector. So what they want is the area of the shaded sector, which is a major sector. So we know the angle right here is 120 degrees. So what you need to do is to look right here for our angle, and we know that the angle at the center is 360 degrees. So we take 120 from 360, we get 240 degrees. Now again, students might look at this and say, oh, 240, but that's in degrees, this is in square centimeter, so this can also be a throw off. And students might opt for 240, but that's 240 degrees. Now 240 is what fraction? Because area of a sector is really pi r squared times theta over 360. But theta here is 240 degrees over 360 times the area of the circle pi r squared, given as 90 square centimeters. So we could say 0 cancels 0. Now in our timetable, we could say 12 into 24 is 2, 12 into 36 is 3, 3 into 3, 1, 3 into 9 is 3, 3 into 0, 2 times 30 is 60 square centimeters. So if we had to work it out, we would have obtained 60 square centimeters. In our first video, we have in the figure below, what is the size of angle X? Now here, as you look at this, you see a triangle, and here you see two strokes right here. Now what does this suggest? Once you see two strokes here and here, or even a single stroke here and here, it suggests that this side equal to this side. Now once two sides of a triangle are equal, it suggests that it must be an isosceles triangle. And so we know that with isosceles triangle, the base angles are equal. So if this is 40 degrees, then this must be 40 degrees. Now right away, you realize that we have a 40 degrees here. But this is not our answer, because what they want is the size of angle X. So this angle X here is called our apex angle. So in order to find X, we use a property of a triangle that some of the interior angles of a triangle add up to give us 180 degrees. So if we have 40 plus 40, that will give us 80. Now we are going to take 80 from 180 degrees to get X. So X really is 180 minus 80 degrees, which is 100 degrees. So if you add 40 and 40 and get 80, you don't necessarily have to write out no equation, because if you know that 180 degrees is the sum of the interior angles of a triangle, by now you should know that when I take 80 from 180, we're actually going to get 100 degrees. So you circle A, which is 100 degrees. Now when we look at this, it says in the figure above, number 12 here, AC is parallel to BD. Please look at the figure while reading to see if the information matches what is on the diagram, or the diagram matches what is in the information. So good. Here you see an arrow, here you see an arrow, suggesting that these two lines are parallel. Now, it says here, now once you look at JETK, JETK is a straight line that actually intersects or cuts the two parallel lines at this point and this point. Now once you have a straight line that cuts two parallel lines, then that straight line is referred to as a transversal. So this is a transversal. Now once you have a transversal, please look out for angles F, angles U, angles X, and angle Z, FUXZ. Now when we say F, it basically our angle look like this, our angle is looking like this, where this line is parallel with this line, and so we have this angle here and this angle, they share something in common. So what happened, please look here. So here is the shape letter F. So the F could also be a sideway F, as long as these two lines are parallel. Then if you notice, this position and this position, they are basically similar. So this angle and this angle are sitting in a similar position. So we refer to these angles as corresponding angles. So right here, let us check something based on our F right here. Right here we have our F. So if this is 100 degrees, then this is 100 degrees, because they sit in a similar position on their transversal. Now, it follows that this angle here and this angle would also be corresponding angles, because then we'd have a backway F as in that. So those are what you call corresponding angles. So it says, what is the size of angle JTB? So immediately you would put 100 degrees. Now what if they had asked us something else? Let us look for U angles now, because sometimes they can give you U. Now U can be in any shape, any position. So this angle here, this one, any orientation. This and this, as long as these two lines are parallel, then this straight line must be a transversal. And so we know that these are two interior angles, but what happened, they are opposite to each other, and because they are together we refer to them as because in the word cooperate means work, co means together, so work together. So we have what we call co-interior angles. Together, these two angles inside this U are what we call supplementary. So in fact, this is 100 degrees. So if you had gotten, say, this one having this, you simply subtract 100 from 180 and you get 80 degrees, because supplementary angles are two angles that add to give us 180 degrees. Now, in terms of the X, you could get X angle. So this in X, they are referred to as vertically opposite, and vertically opposite angles are equal. So if this is 100 degrees, then this is also 100 degrees. If this is, say, 50 degrees, sorry, this wouldn't be 50, this would be 80 degrees, because angles on a straight line measure 180, so this would also be 80 degrees, vertically opposite. And then we'd have Z angles now, which are really referred to as alternate angles. So this angle and this angle are actually equal, and that is a Z. This angle and this angle equal. So right here we could also have a Z, and right here I could show you that here we have an X. So right here in our X, if this is 100, then here is also 100, and if this is 80, then this is also 80. So on a multiple choice exam, look out for something like this. They normally come with one of these questions. So here we have X, here we also have X, here we have Z. So here we have a Z right here, and if this is 80 degrees, then this is also 80 degrees. And we also have another Z right here. If this is 100 degrees, then this is also 100 degrees. Now this is the end of our second video. Look forward to the next video, where we will be looking at questions like vectors, matrices, transformation geometry, okay, circle theorem, and those questions actually can come on the paper. Now what I want you to do is to subscribe to my videos, share and like my videos, and also make comments. Thank you very much.